Our last video here is really this example number 12, any of the chemical reactions that we have talked about in this section. So give the products of each of the reactions involving functional groups. If I were you, I would try to do all these by yourself first, go back in your notes, find the reactions and see if you can predict the products. Now, sometimes you might be a little unsure of what these mean. Okay, so I'm starting with these products or these reactants. If it's an O with a little asterisk, that means I'm going to be oxidizing it. Remember, we talked about oxidizing alcohols. That's what we're going to be doing. So this means that it is an oxidant. Often we use these molecules, so chromates, dichromates, permanganates, to oxidize things. We did a redox reaction with some of these oxidants. And then if I'm doing reduction, I might be using this or something similar, but a reduction would be an R. Okay, so what I'm trying to do is see what happens when I oxidize this molecule, okay? Or what happens when I have a carboxylic acid reacts with this sodium hydroxide. You should be able to do all these based on your knowledge, but I would try them and then I'm going to walk through each of them. So if you want to pause, I would do that now. Okay, so the first ones are all oxidation. So these are oxidations of alcohols. So remember, it does depend on if it's primary, secondary, or tertiary, if the alcohol is going to even react and what the product is going to be. A primary alcohol, which is what this one is, this OH group is on a carbon that only has one other carbon attached to it. So this is primary. Remember that oxygen is going to become a double bonded O, and then an H, and then I'm going to stick another oxygen on there. Remember, it's going to stick as many oxygen bonds on it as possible. So first it turns into this, that double bonded O with an H, and then it turns into this because I added another oxygen. Okay, so instead of it just being OH, now I have a C double bond O, OH. I think I added a carbon. I just noticed I had made a mistake. I don't add extra carbons when you're oxidizing. I only had 2 carbons to begin with. So then I changed it so that I have a carbon double bonded O, and then I added an OH. So it should still only have 2 carbons. I apologize. Okay. I got this one here. This is a secondary alcohol because the carbon that the OH minus is attached to has 2 carbons attached to it. And that means the only thing I can do is change this into a double bonded O. Okay, so I have a carbon double bonded O because I can't get rid of any of the R groups. Tertiary, because this carbon has an OH and then 3 carbons attached to it, there's no reaction because I can't use one of these bonds to make a hydroxide because they're all carbons and I can't get rid of any R groups. All right, now I'm going to look at these molecules. Now you might have been like, we didn't do anything like this and we haven't yet, but you should be able to figure it out. I know this is a type of molecule. This is a carboxylic acid, right? Acids donate hydrogens. So what I would do is donate a hydrogen. Where would that hydrogen go? With that hydroxide. So H2O. And now I have this new compound, the ionic compound. The sodium, which is Na+, goes with whatever's left over here. And this is minus. So you could write it like this. You could write it, you could do the ionic reaction if you wanted to. I could do Na+ plus CH3 C double bond O minus. You can get rid of these plus and minus if you want to. However, you can show that a hydrogen was lost because carboxylic acid is an acid. So if I react it with a base, they are going to neutralize each other. Same thing here. This is an amine. Remember, anytime you have a nitrogen, that's a weak base. Bases accept hydrogens. So if I'm reacting with an acid, this hydrogen is going to go on to that nitrogen, and I'm left with the Cl minus. So the hydrogen goes on to that nitrogen. That's how they get that NH3 plus. And I have a Cl minus because it lost that hydrogen. So anytime you've got a carboxylic acid, acts like an acid. Anytime you've got an amine, acts like a base. Now, these last 2 are the reactions that make esters or amides, okay? So I have a carboxylic acid. Remember, for both of these, I start with a carboxylic acid. And then if I am adding an alcohol, then that's going to make an ester. And if I am adding an amine, that's going to make an amide. So remember, I lose a water molecule, and then the other thing, the rest of this attaches to it. So my new molecule looks like this. This didn't change. And then it's an oxygen with this methyl group here and a water. So, right, I took out a water, this OH and the H came out, and then I had an ester. Same thing happens here in a carboxylic acid. This OH and an H come out and make a water. And then the nitrogen attaches here to that carbon. So now I have this R group is still here. This is an ethyl, C double bond O, N, and there one of those H's is still there because nitrogen's got to have 3 bonds, CH3. Okay, so nitrogen's gonna have 3 bonds. My amide is gonna look like this. If you want to draw it out with the bonds for your products, that is also fine. Whatever makes it easier for you to figure out.